Jai Hind to all of you. I am Dr. Himani Garg, working as professor in Department of Electronics and Communication Engineering at Akgec Engineering College, Ghaziabad. Today I am going to discuss about an important topic, that is cellular infrastructure, that comes under the subject wireless and mobile communication. In my last video, I had discussed about cellular systems, in which I had discussed that what shape of the cell size should be there, which type of shape should be there, and how the frequency reuse is done, and all other factors. Now we will dive deep into another effects of cellular infrastructure. Now firstly we will come about the antenna that are used for cellular system. So two types of antennas are used for cellular system, that can be directional, omnidirectional and directional. Two types of antennas are used, that can be omnidirectional and directional antenna. So this is the picture showing the omnidirectional directional antenna. Now what are these omnidirectional antenna? Omnidirectional antenna will be radiating in all the directions. So its beamwidth will be radiating in different directions, and nothing but the dipoles, and they radiate in all lateral directions. Now when we talk about directional antenna, shapes and projects a beam of radio energy in a specific direction. From the name itself it is clear, omni means it is radiating in all the directions, whereas in directional antenna that will be radiating the power in a particular direction. The term beamwidth is used in the case of directional antenna because the beamwidth will show that the maximum power will be in that particular area. So beamwidth will be there. Conical size of the radiated beam. Down tilting. The radiation pattern of a down tilt antenna is electrically or mechanically tilted downwards at a specific number of degrees to avoid shadowing with the other antennas. So there is some down tilting angle is also described. Now for the base station of the cellular system, the important points are size of the area to be covered. So if you are talking about covering a large area, then we will be definitely using very large height of the antenna height will be more than the area in which we are using if we have to cover smaller area. Then what is the configuration of the neighboring cell sites? That is also taken care while selecting the antennas. Omnidirectional and directional antennas are used. Antennas beamwidth in the case of directional antenna, and allotted RF spectrum. As in mobile communication, we will be having a particular radio frequency spectrum that will be used. So whenever we are designing an antenna or using an antenna, this is an important factor, that we are working it which frequency range. Now probable adverse effects of base stations. Nowadays we are hearing that base stations are, the power radiated by the base stations is causing adverse effects on the people. And it generally affects the people in the urban areas because the distance between the antenna and the urban people is less. So the power that is being radiated by these antennas, that will be in direct contact with the human beings. So the probable adverse effect of the radiation from the base stations are a major concern, especially among residents in urban areas. Independent monitoring of RF exposure levels around mobile phone base stations has been conducted for many years by the government. Now next we will discuss about the operations of cellular system. First is how the call is originating. Then the call can be originated in the case of cellular system, that can be mobile originated call. As you can see in the last video also, we had discussed that we are having a particular cell, in which cell we are having the BTS, base transceiver station. This is our mobile station, and then we are having, this is connected to the BSC is connected to the MSC, and this is connected to the PSTN, and it is connected to another BSC or BTS. Now in the case of mobile originated call, as you can see, when the call is originated from the mobile itself, then this mobile will be connecting the nearest BTS. The BTS will connect to the BSC. The BSC will connect to its MSC, and then accordingly it will make the call to PSTN, or it will connect another BSC or MSC or BTS that is in the another cell, right? So these are two possible in mobile originated call, mobile to mobile call and mobile to landline. PSTN stands for landline. public switched telephone network. As an example, the call setup sequence for mobile originated call in, this is the example for GSM system, when there is a call originated from the mobile. Now, when there is mobile terminated call, you can see here, we are having PSTN, public switched, or can be BTS or BSC. It will connect call is being terminated at the mobile station. That's why there will be call coming from here. It will be going to the mobile MSC, it will then going to the BSC and to the BTS, then to the mobile station. So this is mobile terminated call. Next up, mobile originating calls are routed to the BTS first and then to the BSC. BSC forward this call to the MSC. The MSC authenticates. Now what we mean by authentication here? Authentication means MSC checks the authentication of the number from which the mobile station is calling. So we have already discussed about HLR, VLR, home location register, VLR, visitor location register, authentication. All these things are taken care by the MSC. So he authenticates whether the number from which the user is calling is authentic or not, and routes the call to the call subscriber as per the dial digits. If the call subscriber is in mobility, the process to receive the call on his mobile device, obviously that's why we are talking about mobile communication. In mobile terminated communication, the call is coming from MSC and then it is going to where the HLR VLR query is carried out, and as per the information, MS is paged in the suitable BSC. The BSC forward this page to all BTS where the actual paging is done. After BTS gets a response from the mobile, obviously the mobile to which the user has made a call, it allocates a channel for this. On the ending, the BTS informs the BSC and the MSC. So this is the how the steps are taken when there is mobile originated call or mobile terminated call. Now, if I am talking about network originated or landline originated call, landline, that in the last slide we had discussed about public switched telephone network. So if the call is coming from the landline, that means the user that is calling is not mobile, he is stationary and he is calling from landline. A feature called registration is used for landline originator calls. A landline user dials a mobile unit number. We are dialing the number. The telephone company's zone office recognizes the call is for a mobile number and forwards it to MTSO and mobile switching center. This sends a paging message to certain cell sites based on the mobile unit number and the search algorithm. Each cell transmits the page on its own setup channel. If the mobile unit is registered in a particular cell, the register sites pages the mobile that somebody is trying to call you, he sends the messages or pages these messages. The mobile unit recognizes its own identification number because every user is given a particular mobile number, that is his identification number. So the mobile checks that this is my identification number. On a strong setup channel, locks onto it and responds to the cell site. The mobile unit also follows the instruction to tune to an assigned voice call and initiate users alert that this call has started. Now, call termination, when the mobile, obviously when all the things, when the call has been done, the user has stopped, then there will be termination of the call. When a mobile user turns off the transmitter, a particular signaling tone is transmitted to the cell site. Tone means in the terms of frequency, and the voice channel is freed for both the sides. So voice channel is a frequency allocated to the user so as to communicate. So that channel will be free. Now we can use that frequency for other user. The mobile unit resumes monitoring pages through the strongest setup channel. So whenever the mobile is, when we are not on any call, then our mobile keeps on paging and checking that whether everyone wants to make call, as well as it keeps on checking the power from the nearest base station. Now, very important concept in cellular system, that is handoff. As we have said that we have divided the area into cells. Whole area is divided into cell and each cell is having its own base station. So, whenever and we are using a mobile station is there. So whenever we are moving, when we are on call, and whenever we are moving from one cell to another cell, obviously we are coming under the control of going from the control of one base station to the other base station. So there are chances that if you move to the other base station, then the call will be dropped. Now, so as to provide you with the services that your call is not dropped, we are using the concept of handoff. So the cellular infrastructure uses the concept of handoff. So in general terms, handoff or handover means if you are on a call and we are in a particular base station under the control of one base station, and if we move to another base station, then the first base station will hand over our call to the next base station if we are on call, right? So that our call is not terminated. So we will discuss about this cellular system handover process. In cellular telecommunications, the term handover or handoff refers to the process of transferring ongoing call. Try to remember this thing. Here we are talking about only ongoing calls or data connectivity from one base station to the other base station. When a mobile moves into different cell while the conversation is in progress, that I am talking and I am moving from one base station to the other base station, then one base station will hand over my signal to the other base station. Then the MSC, this is done by the MSC, Mobile Switching Center. Transfer the call to a new channel belonging to the other base station. So it is going to the other base station. When a mobile moves into different cell while conversion is, MSC automatically transfers the call to a newer cell belonging to new base station. Handoff not only involves identifying a new base station, but also requires that the voice and control systems be allocated to channels with the new base station. Obviously, whenever we are on call, that means that base station has provided us with a particular frequency so that we can communicate. We are provided with a particular frequency so that we can communicate. And if you are using the mobile in conversation, that means we are using the voice channel, we are sending the signal. So if you move from one base station to another, then the other base station should provide you with the voice channel as well as control channel. Both these channels should be provided to you. Handoff must be performed successfully and as infrequently as possible. So this is the handover should be smooth, so that the person who is on call should not be able to know that he has moved from one base station to another base station. So its frequency has been changed from one to another. As well as if the mobile MSC should take the decision properly, that there shouldn't be frequent handoffs. Otherwise, what will happen if there will be frequent handoff? Then there will be a burden on the MSC, and the MSC will keep on sending changing the frequencies of the user from one frequency to the another as he moves from one base station to the other base station. For this, system designer must specify an optimum signal level at which handoff is to initiate. The handoff depends upon the power. If our signal of power keeps on decreasing, that means our call will be terminated. So it is very much important to check when the call, when of the power signal, this power should be always be monitored, so as to know when proper handoff is required, so that our call is not terminated, as well as frequent handoffs are not there. Both these things has to be taken care of. Once a particular signal level is specified as a minimum usable signal for acceptable voice quality at the base station, a slightly stronger level is used as threshold at which handoff is made. So two signal levels we are taking. One is the threshold level and another is the minimum level that is required to keep the signal. Otherwise, our call will be terminated. So this delta, this margin delta is given by power that is required for handoff minus minimum usable power that we can have while we are moving and our call is connected. So you can see this diagram. It will be more clear from this diagram. if I talk about improper handoff situation and proper handoff situation. In improper handoff situation, you can see on the x-axis we are having the time, and this is your received signal power. So this is the signal power at point A at this particular time. Now the user is moving, and what is there? We are having another level, that is handoff threshold level, and this is the minimum acceptable to maintain the call. So you are having two signals, is the minimum acceptable, and another is the stronger threshold signal. So you are having two signals that we have to compare. This is the threshold and minimum. So the base MSc has to take the decision between this particular zone, that whether to have handoff or whether to not have handoff. Now this particular base station has not taken the decision of handoff at this particular point, and the signal power has gone below the minimum acceptable signal to maintain the call. So that's why at this particular time the call is terminated, because the power has gone below the minimum acceptable level. Whereas you can see in this case of proper handoff, level at which handoff is made call properly. At this particular point, when the power is not below the minimum acceptable level, the decision to handoff has been taken off. That's why the signal has been shifted from base station 1 to base station 2, and proper handoff has taken place. So this is the case with proper handoff. So you have seen both the improper and proper handoff. So today we discussed about some ideas about cellular infrastructure, in which we discussed about antennas. That means we are using omnidirectional, directional antennas, and the height of the antennas, that will depend upon the usage, how much area we are covering, and other factors also. So we had discussed about the adverse effects of antennas. Then we discussed about the different types of calls, mobile originated call, mobile terminated calls. We discussed about these, and then the important concept, that is handoff. We have started with the handoff. So whenever we are in, the call is in progress and the user is moving from one cell to another, then handoff has to occur. So we discussed about this. The threshold level is there, and then the minimum voice quality level is there. So we discussed about these things. For the rest of the topics we will be discussing in our next lecture.